So in this case, we are going to consider our revision for our mathematics grade 10, which is November 2023 exam for our paper one, as we are to consider our full paper revision, that is 2 hours, and that is 100 marks that we need to look into. So make sure that you go through your instructions, the information that you are given, especially all the working is supposed to be shown properly, and also where necessary, answers should be rounded off to 2 decimal places unless stated otherwise. So you're supposed to make sure that your answers are to 2 decimal places unless you're given any other instruction. So rushing through our questions, on question number one, you were being given to determine without the use of a calculator, meaning to say the calculator is not required, okay, between which two integers square root of 112 lies. It's a question between, determine without using it, between which integers are we going to have. So if you're answering this type of a question, just for you to be careful. Yes, they say do not use a calculator, but you can just use a calculator to, just for you to know the numbers approximately that you are working with, because this number that we are having, it is not an integer, all right? Let's just say we have our calculator like this. The square root of 112. Just verify your calculator is there just for you to note. Okay, at least you know that you are dealing with a number which is 10,58. Square root of 112, 10,58. 10,58, it is telling us this number here, all right? We have got 10,58. You're not allowed to use a calculator, remember? But this can just help you to note. Let's say you are not into these numbers. At least you can tell to say, the numbers that I'm going to work with, it is the number in between 10,58, and it must be an integer. Remember your integers, those positive or negative whole numbers, 1, 2, 3, and so on. So which number am I going to work with that is below 10,58, but it's a whole number, it's an integer? So we've got 10,5, 10,4, 10,3, up to a number which is 10, which is an integer. We move on 10,58, 10,6, 10,7, and so on, up to a number which is 11. So if you understand at least that way, you know, okay, so if it is 10 that I'm waking up with, 10, where was this 10 taken from? Because this number here under the square root, it is simply means we have a square. Like 10 squared is what? It's 100. What about 11 squared? This is 121. So as the numbers that we can consider between 112, where we can obtain the square root, because we cannot obtain directly the square root of 112. It is not giving us an integer. So we have to check the numbers which will give us what? Integers. So the 10 squared, which is 100. So this is less than this one. The square root of 100 is also less than the square root. This is bigger than the square root of 100, but less than the square root of 121. These are the numbers, the perfect squares, which will give us these 10 and 11. The square root of 100 is what? It's 10. So these are the numbers that we're talking about. So the square root of 112 is bigger than 10, but it is also less than 11. That is the numbers, the boundaries that are governing these two integers, which are in between. We are talking about the 10 and the 11. But as you know, guys, from that, you can even tell. So they said do not use a calculator, but you can just use a calculator, guys, to see which number is it that I'm talking about, which number, where is it in between? So meaning to say the square root of 112 lies between, it lies between 10 and what? 10 and 11. These are the integers. That is where we are going to have this number. So guys, so many ways that you can actually work with. Simplify fully that is same as simplify completely, evaluate completely. What is it that you're supposed to simplify? 1.21. We are given x minus 1 plus x squared in one bracket into the bracket of 3 minus x. So this is definitely expansion of brackets, expanding. So this bracket has to multiply everything in that bracket. You can even read it like, as you can see, there are how many terms here in this bracket? 1, 2, 3. Here, 1, 2. So it is easier for you to start with this one with 2 terms. Not to say even if you use that one, it's wrong. No. If you use this, it is easier because you're just working with what? 2 terms. So you can even rewrite. Remember that A times B is the same as B times A. So we can also rewrite starting with 3 minus x, multiplying the whole bracket of x minus 1 plus x squared. All right. So let us expand. Remember, on expanding, the 3 that we are seeing is going to multiply each and every term. So this 3 is going to multiply each and every term in the second bracket, meaning to say 3 is going to multiply x. We distribute that by 3. 3 times x, that is 3x. 3 multiplies the following term, which is minus 1. 3 times minus 1, that's a minus 3. The 3 multiplies the x squared at the end. So this is going to be plus 3x squared. 3 has multiplied each and every number that you're given. After that, you consider the part of minus x as it is the minus x that is remaining, the whole part of minus x. Just like what we saw on minus 3, it must also expand everything in the second bracket. So that's minus x times x, which is minus x squared. That is what we have there. We do the same, minus x, it multiplies minus 1. So there's a minus, minus, and a minus. That's a positive. That's positive x. We do the same. The minus x multiplies the positive x squared. So it's minus and a plus. That's a minus x to the exponent of 3. Remember, these are 2 and there's a 1. So we add 2 plus 1, which is 3. At this stage, we can collect the like terms. X to the exponent of 3, we just have this part. That is the only part that we have of x to the exponent of 3, which is a negative. We look into x squared. All right, there is an x squared, there's an x squared. So there we've got a number here which is same as minus 1. So we are considering the part of x squared. Here there is plus 3x squared, and this one is minus 1x squared. So it is simply 3 minus 1. That is what we have in 3 minus 1, which is 2. So that is going to give us 2x squared. The same part with our x. Even on this part of x, there is x here. We also have x on this part here. This is x. So these are like terms. So we can add this. This is same as we have got 1x. So it's 3 plus 1, which is 4. So that's 4x. And we just have this constant minus 3. So we are just going to write that minus 3 as it is. That is the only constant that we have. So we cannot refer any addition of any term there. Just have to write as it is. So that was our question there on question number 1.21, having 3 marks. Then considering 1.22, simplify. What is it that you're supposed to do in this case? We can see that is simply subtracting and adding of what? Of fractions. So we are given x plus 1, everything over 2, minus 1 minus x over 17, plus 7 over 34, like this. And this is addition, subtraction combined. So you can simply find the LCD or the LCM of these numbers 2, 17, and 34. What is the LCM? So you can see that the LCM is 34. It carries these two numbers, 2 and 17. They are found in 34. So we can use 34 as our LCD or our LCM. Remember the concept, you divide 34 divided by 2. What are we going to have if you divide 34 by 2? That's a 17. Whatever that you obtain is going to multiply the numerator as it is. So the numerator is an expression, so it's best for us to end with an expression. Start with the number, then the expression. Any way that you understand, you can even write it as x plus 1 times 17, as long as you understand what is it that you are doing there. You do the same thing to the next term, 34 divided by 17. That will be a 2, but there is a negative. Take note there. So it will be minus 2 into the bracket of 1 minus x. Same thing, the 34 divided with the 34, that is a 1. So that's plus 1 into a 7. Whatever that you get multiplies the numerator. So the 1 is going to multiply the numerator. Expand your brackets. 17 multiplying the first bracket, everything in the first bracket. That's 17 times x, which is 17x. 17 times 1, which is 17. The second bracket multiplied by minus 2. So that is minus 2 times 1, which is minus 2. Minus 2 times minus x, that will be positive 2x. Take note, negative and negative. Then 1 and 7, that is going to give us a 7. Everything over 34. So you write everything divided by the LCD or the LCM. Then at this stage, you can consider your like terms, the part of x, that is 17x plus 2x. So you can simply add these terms of x together, meaning to say we are going to have 17 plus 2, which is 19x. Then considering the constants, the part where we do not have x, we can consider 17 minus 2 plus a 7. So that is 17 minus 2, which is going to give us 15, then 15 plus 7, which is going to give us 22. So that was going to be positive 22, everything over what? Over 34. Yes, you can separate this as 19x over 30, but as a single fraction, guys, in simplest form is supposed to be this way. To simplify, it's supposed to be a single fraction in its simplest form. There is nothing common between 19 and 22. So we cannot factorize. If there is anything that is common, then we have to consider factorization to be done. So questions can be like this, guys. This is how sometimes you are given your questions. You just have to be careful in your simplification. On 1.23, still on the simplification, simplify this fully, and we are given that's 1.23, 4 to the exponent of x plus 3. So take note there, we've got 4 to the exponent of x plus 3, multiplied to 8 to the exponent of 1 minus x, multiplied to 2 to the exponent of x minus 9. So like I said before, as long you are dealing with exponents, as long you are working with exponents, try by all means to have your numbers in simplest form. In simplest form. So the simplest form is rewriting these numbers as prime numbers, So considering 4, it is same. 4 in 2 divided by 4, that is 4 divided by 2, which is 2, then 2 again. So 4 is same as 2 times 2. And we know, guys, 2 times 2 is same as what? 2 squared. 2 is a prime number, remember? Divisible by 1 and itself. So in place of 4, we can write 2 to the exponent of 2. But already there is an exponent which is given there of x plus 3. You do the same thing on 8. So if you're to consider 8, guys, we're going to see that there is 2 times 2 times 2, 3 times. Or you can simply divide by 2, that is 4. You divide by 2, that's a 2. You divide by 2, that's a 1. So 2 times 2 times 2, 3 times. That is 2 to the exponent of 3. So 8 is same as 2 to the exponent of 3, raised to the exponent of 1 minus x, as a prime number. 2 is already a prime number. Remember, 2, there's just a prime number, so it's already in simplest form. There's nothing that we can do on this 2. It's already in simplest form. You can expand the brackets. Remember the concept of an exponent to an exponent. Simply expand the brackets. Then you can consider another law. So that's 2x, 2 times 3. Remember, you're distributing by 2. So that is a 6 times 2 to the exponent 3 times 1 here. That is 3. 3 times minus x. That is minus 3x. Then the same, this part we cannot simplify anything. It's just rewriting as it is. As we can see, we have the same base, the base of 2. It's base of 2. There is 2 here. There is 2 here. There is 2 here. The exponents are already in a simplified manner. Then we have already simplified our exponents. So let's consider that we are multiplying the same base. What are we supposed to do? If you're multiplying x to the exponent of a and x to the exponent of b, remember you're supposed to add exponents. So we are supposed to add everything that we're given. 2 to the exponent of 2x plus 6. We add this other exponent, which is 3 minus 3x. We also add this other exponent of x minus 9. In actual sense, we're supposed to put the brackets here, but adding, there's no need for that. Subtraction, you are supposed to put the brackets, but for addition, just write your terms as they are. Take note, this is under the same base of 2. Under the same base, just like what we had there. So meaning to say this can be simplified, considering our like terms, just like before, we have the like terms, the part of x. This is 2x, this is minus 3x, and this is plus x, which is same as 1x. So if we were to simplify there, you're going to obtain a 0 there. That's 2 plus 1, which is 3. 3 minus 3, that's a 0. So in terms of x, that was going to cancel. The numbers, we've got 6 plus 3 minus 9. So 6 plus 3, that's 9, and 9 minus 9, that's a 0 again. So this was going to be 0, and 0 plus 0 is what? It's 0. So 2 to the exponent of a 0 is 1. Remember, any number, when being raised to the power or to the exponent of a 0 is 1. So 2 to the power of 0 there was going to give you a 1 at the end. So this is how sometimes your questions might be given, as you just have to revise as much questions as you can. Prepare yourselves for the exams that are ahead of time. 1.3, factorize. This is not to simplify, but it is to factorize, and we're supposed to factorize completely or to factorize fully. All right. That's 1.31. Let's start with this one. 1.31, we were given x to the exponent of 3 minus 10x squared plus 21x. Remember the golden rule. If there is anything common, factor that first. Between these three terms that we are given, 1, 2, 3, is there anything that is common? We can see that x is common. We have got x here, we have got x here, we have got x here. So we can factor out that x, which one that has got the smallest power, that's your highest common factor. This is x to the exponent of 1. So we're going to factor out x. After factoring out x, we divide. X cubed divided to x. X to the exponent of 3 divided by x. How many are they? They are 3. So if we divide by 1 into these ones, which were 3, how many are going to remain? We are going to remain with 2. X squared. Same thing on this minus 10x squared. You do the same thing. Divide by what? Divide by x. So x, there are 2 of them. You divide by 1x. How many are going to remain? It is only 1. So that is minus 10x. Same thing with that 21x. You divide it to x. So x and x was going to cancel. So that was going to be plus 21. It's very true that you have factorized, you factored out x, which was common. But the question is it in simplest form? Is it fully factorized? If we are to consider, we are going to see that there is a quadratic expression that is remaining here. We have a quadratic expression that is remaining. Can we factorize that quadratic expression? When the coefficient of x squared is 1, guys, this one is direct. We can just try. This is x. Remember, we are supposed to have 2 brackets. We try this. That is 21. Are we having 2 numbers, the products of 21, or the factors, 2 products that will give you positive 21? But the same products, when you add these products, you must get a negative 10. 2 numbers. So 10, we can simply work with 7 and 3. But it must be a negative 10. So how can it be a negative? Because 7 times 3, it gives us 21. So how can we also obtain a 21 from these same numbers? We can put a negative here and a negative. minus 7 times minus 3, that's a positive 21. If we add minus 7 plus minus 3, we are going to get a minus 10. So these are exactly the numbers that we want. X minus 7, another bracket, x minus 3. Just like that. This is now fully factorized. We have factorized fully, where we do not have anything common. We do not have any difference of two squares. We do not have any quadratic type of an expression. No, it is fully factorized when it is like that. On 1.32, you're supposed to do the same thing. X squared minus z squared plus x plus z. So the first thing, is there anything common? There's nothing common. We can say x is not common. Here we do not have x. Here we do not have x. Z is not common. But there's something between these two terms. This one, it's a presentation of a difference of two squares. Remember, when you refer to your difference of two squares, when you are given a squared minus b squared, it's the same, x squared minus z squared. Two brackets. One is going to subtract x minus z into what? Into x plus z. One subtracts, another one is going to add. Difference of two squares. This part, it's a difference of two squares. The remaining part, there is nothing that we can do. Just write it as what? As x plus 7, as x plus z as it is. But if we consider this properly, we can see that this one, please take note here. This one, it is now referred as a single term. Yes, these are brackets. I do know. We do know that these are two brackets. An expression and an expression. But because it's a product, take note, this one, it's a product. These two. It's a what? It's a product, this part that we are seeing. So we can refer it as a single term, not as an expression, because it's a product, this one. Just as remember, if you're given two terms, A times B, it is equal to AB. It's now a single term. You refer it as a single term. So this is what I'm trying to say. This is a single term. So we can also try to have also the same presentation on x plus z. So we can just have this as x plus z like that in a bracket. Meaning to say, this is a single term. This is also a single term because it's in a bracket. We just considered like a term, like because it's in a bracket, but it's an expression like x plus z. But just consider like as a single term. What is it that we have? Because these two terms are separated. This term and this term, they are separated by a sign in between. So factorization can happen between these two terms. We just have to factor out what is common. X plus z is common. So factoring out x plus z, what are we going to remain with on the first term, this one? If you factor out x plus z, it will divide x plus z, and this x plus z will divide. You remain with what? With x minus z. So you're going to remain with x minus z. You do the same thing. X plus z divides with this x plus z. What was going to happen, guys, if it divides it? Nothing. We're going to remain with a 1. It has divided. It's x plus z over x plus z. They are the same. They cancel. You get a 1. So that was going to be a plus 1 that is remaining, a plus 1. Is there anything that we can factor out between these two terms that is common? No, there is nothing. So meaning to say, this is the simplest form that we can have our answer as. So you see, guys, they'll be testing you the difference of two squares. After that, can you use any other part that you are able to, according to your basics of your mathematics? 1.4, solve for x. It's now an equation. Whenever you're given to solve, you are supposed to find x. That is an equation. We are now dealing with what? An equation. That is where you solve. Expressions is where we simplify. This simplification is done on expression, but this is now an equation. There's an equal to there. So we are given solve for x on 1.41, the bracket of x minus 3, that's x minus 3 into the bracket of 2 minus x is equal to minus 2x like this. And they are saying solve for x. So we can see that there is nothing common. We cannot use the zero concept where we say this is equal to this is equal to this. It only happens on the zero concept. Let's say it was x minus 3 into the bracket of 2 minus x, it is equal to 0. We can say this is equal to 0. This is equal to 0 also as two equations. But it does not happen when they are giving us a term or an exponent, any other number besides a 0. It can only happen when it is a 0. So meaning to say, in this case, we are stuck. The only way is to expand these brackets and see the type of equation that we are going to have at the end. So by FOIL method, remember, you're supposed to expand this bracket of x minus 3. The x multiplies everything in this other bracket that we are given. All right, so let's multiply and see what you're going to have. That will be x versus 2. So that is going to be 2x. Then x versus minus x. X times minus x is what? Minus x squared. We are done with x. We move on to the other term or the other number, which is minus 3. Distribute just like the previous case. Minus 3 multiplies everything. Minus 3 multiplies 2. That was going to give us minus 6. The minus 2 multiplies the minus x. Minus, that's a plus. So it was going to give us plus 3x, which is equal to minus 2x. So let's simplify the left-hand side, considering that we have got minus x squared, which is the highest exponent, is on that squared. Then we can consider the like terms here, the 2x and the 3x. These are like terms, same variable, same exponent. The exponent is 1. So we can simply add the coefficients 2 plus 3, which is 5. So that's 5x. We are remaining with what? With minus 6. So that's minus 6 is equal to minus 2x. So as you can see, guys, we have formed a quadratic equation. The highest exponent there is 2. That's a quadratic equation. So remember the format of a quadratic equation. Ax squared plus bx plus c is supposed to be equal to 0. One of the sides is supposed to be equal to 0. So you can take the minus 2x this side so that it will be a positive the moment it crosses the equal sign. So that will be minus x squared. So if we take this to the other side, it will be a plus. So it will be like this, 5x plus 2x, 5 plus 2, which is 7. So that's 7x minus 6 is equal to 0. We just need to let one of the sides to be equal to 0. We can solve this equation, which is fine, but we can also try by all means to avoid working with minus x squared, guys. We can do that. How can we avoid working with minus x squared? You can divide by minus 1 each and every term across equation. Divide by negative 1. So this one and this one will cancel. You have got x squared. 7 divided to minus 1. That's minus 7x. Minus and minus cancels. That's a positive 6, which is equal to 0 divided by minus 1. That's a 0. Remember that 0 divided by any number, it will remain as a what? As a 0. This is now, guys, as we had this part where you are asked to factorize, remember here when you factored x, you were left with x squared minus 10x plus 21. You factorized this using the normal approach of your quadratic expressions. This is the same thing, guys, from the zero concept. Remember the zero product. If we factorize, we know that we are going to have 2 brackets. So by factorization here, we are going to have 2 brackets by factor. It's a quadratic expression. The coefficient is 1 of x squared. So you're just going to have x and x. What are the factors of 6? The products. 2 numbers. You multiply these 2 numbers, you get 6. But when you add the 2 numbers, you must get a minus 7. So as you can see, 6 and 1, there's a possibility of us having a 7. But there it is minus 7. So how can we have it? Minus 1, minus 1. If we multiply minus 6 and minus 1, that's a positive 6. If we add minus 6 plus minus 1, that's a minus 7. So the numbers there is minus 6. Another one is minus 1. Remember, it's an equation, so it is supposed to be equal to 0. You equate everything. You're equating to whatever that you're given there. So from the zero concept, one of these brackets is equal. Remember what I was explaining before, that if there was a 0, you're going to use that. So now we have the 0 there. So it means x minus 6 is supposed to be equal to 0, or the remaining part of x minus 1 is equal to 0. So what is going to be the value of x? Minus 6 to the other side becomes a positive, which is 6. Or x is going to be minus 1 to the other side. It becomes a positive. 0 plus 1, that's a 1. So at the end, you're going to have two possible values of x from this equation. So you see, guys, study your question, understand what you're given on that information. On 1.42, we are given again to solve for x. 3 to the exponent of 3x minus 1 is equal to 27 to the exponent of x minus 18. If we are to consider the part of x, because that is the most important part, where x is, the part where we have x here is 3 to the exponent. It is the simplest form. 3 is a prime number. Remember, I said simplest form when you're dealing with exponents is to work with what? Prime numbers. 3 is a prime number. But if we check here, we also have x, but look at the number that is given. 27 is not in simplest form. 27 is not in simplest form. As a prime number, 27 is same as what? 27 is same as 3 to the exponent of 3. Or you can have it 27, you divide by 3, which is 9, by 3, which is 3, by 3, which is 1. As you can see, 1, 2, 3. 3 to the exponent of 3. So it means this was supposed to be written as 3 to the exponent of 3x minus 1 is equal to, in place of 27, it is going to be 3 to the exponent of 3 times x. There is already x there. So remember, exponent multiply. So it will be to the exponent of what? Of 3x minus 18. Do not worry about that 18 because we do not have x on this 18. So even as it is like that, just leave it as it is. So if I am to consider properly, I'm going to see that there is a negative 1. Remember, I explained this if you checked November 2022 exam, where we had a negative and I said, whenever you've got this, it simply means you were dividing. That's where you subtracted 3 to the exponent of 3x divided by 3 to the exponent of 1. Remember, if you're dividing the same basis, you subtract the exponents. So you can rewrite as it was before. It was supposed to be 3 to the exponent of 3x over 3. 3 to the exponent of 1 is same as what? Is same as 3, which is equal to 3 to the exponent of 3x minus 18, as we have here. There is a fraction, so you can remove the fraction, simply multiply each and every term by 3, because this is same as over 1, this is same as over 1, so there is 3, 1, and 1. So the LCM or the LCD is 3. Multiply by 3, multiply each and every term. So that was going to cancel. We have got 3 raised to the exponent of 3x is equal to 3 to the exponent of 3 times 3. It is same as 3 times 3 to the exponent of 3x, like this, minus 18 times 3, which is 54. That's a negative 54 there. So we want to solve for x, and we can see that there we have got common terms. We've got like terms here. 3 to the exponent of 3x, 3 to the exponent of 3. These are like terms. So we can collect the like terms. It's either we are going to take this to the other side, or we are going to take this one to the other side. It's up to you, as long as you understand that those are like terms. So let's say we take this 3 times 3 to the exponent of 3x this side. It is going to be 3 to the exponent of 3x. This one, the number there is just like the 1. So just like 1 minus 3. Remember, it was a positive. The moment it crosses the equal sign, it becomes a negative. 3 to the exponent of 3x, which is equal to minus 54. So let's consider that these are like terms, as I said before. So we can simply subtract 1 minus 3, which is minus 2. So that's minus 2 times 3 to the exponent of 3x, which is equal to minus 54. What is it that you need? Value of x. This minus 2 is just on a product. So you can easily remove that by dividing by that. So divide by minus 2 both sides. 3 to the exponent of 3x is equal to what? This one and this one, that's a positive. So 54 divided by 2, that is, we are going to obtain 27. In that case, can we determine the value of x? If 3 to the exponent of 3x is equal to 27, it is only possible if we have same bases between 3 and 27. So we saw before that this 27 is same as 3 to the exponent of 3. We saw that we had this before. 27 here is the one that we wrote as 3 to the exponent of what? 3 to the exponent of 3. So it does not change because of this. Still, we have the same condition. So 3 to the exponent of 3x is equal to 27 in the base of 3. That's 3 to the exponent of 3. Thus, if the bases are the same, we know that the exponents will be equal. Therefore, 3x is equal to 3. So you can divide by 3 to obtain the value of x. So meaning to say, x was going to be 1. So questions can be given depending with the type of exponent or an exponential equation that you are given, but you just have to try to follow the stages, stage by stage. Just try to work your question stage by stage. On 1.5, it was now for you to solve for x, where x is an real number, and that's an inequality, compound inequality, or the simultaneous inequality that you are given there. That's 1.5. So we are given 2x minus 1 over 3 is greater than or equal to minus 3. But the same 2x minus 1 over 3 is less than minus 1. So this is what we have. We can simply work with what you want, guys. You want to remove the 3, which is in the denominator, which is a fraction. So you can simply multiply by 3. Whatever that you're doing here is supposed to be done everywhere. Multiply by 3 to remove the fraction. So meaning to say 3 times minus 3, that's a negative 9. So negative 9, then we're going to remain with 2x minus 1 is less than minus 1 times 3, that's a minus 3. So we have this now. We've cancelled. What is affecting this time? There is a minus 1. So how can we get rid of the minus 1? We have to transpose that minus 1. Take it to the other side. It becomes a plus 1. Take it to the other side here. It also becomes a plus 1. It was a minus. The moment it crosses the inequality side, it must change. It's that will be a plus. So minus 9 plus 1, that's minus 8. So that was going to give us negative 8 less or equal to. So remember, the purpose of taking this, we are going to remain with what? 2x there. So it is going to be 2x is less than minus 3 plus 1, which is minus 2. So transposing of the number minus 1 does not affect the inequality sign. It only affects that number to say it was a minus, it's going to be a positive. The only part where the inequality sign is affected is when you divide by a negative or when you multiply by a negative. So if we check here, we now have 2x. What is affecting x is the 2. So you can simply divide by what? By 2. That's obtaining inequality that is representing x. Nothing is going to change. Remember, you're dividing by 2. So nothing is going to change. So x is greater than or equal to minus 4, but less than minus 2 divided by 2, which is minus 1. So that is the inequality. That is the solution that you were going to have at the end, considering the values of x or the x values within that consideration that you have. So you can even solve this at once. Just solve that at once. Let's consider 1.6. On 1.6, we're given the sum of 3 consecutive integers is 39. Determine with the use of an equation the 3 numbers. Okay, these are consecutive integers, meaning to say one after the other, following each other, integers following each other. what is the relationship that we have on integers? Let's say you are given integers. We know integers, guys, just like 1, 2, 3. That is being consecutive, one after the other. You will see that on each and every integers, as long they are consecutive, as long they are following each other like this, as long they are following each other, there's going to be a difference of 1 in between. 2 minus 1, which is 1, 3 minus 2, which is 1. There is going to be a difference of 1. This is what we know basically for all integers. For any integer that you think of. The next one, if you start with the 2, the next integer, you just have to add 1. 2 plus 1, that's 3. You move on, you add 1, 3 plus 1, which is, and so on. These are integers, whole numbers. Positive or negative, whole numbers. Consecutive, that is the main. So if that is the case that there's a difference of 1, and as we do not know these numbers, because these numbers we do not know. So let x represent the first number and see what's going to happen. Let's just say, let x be the first number. Be the first number. So if x becomes the first number, if we choose x to be the first number, just like you choose to say you are starting with 11, what will be the next integer if they are consecutive? It'll be plus 1. 11 plus 1, which is 12. And this is how we are going to have it. So if we consider to say the first integer that we have is x, what about the second one? The second one will be x plus 1. That will be the second number that we have, the second. All right, this was 12 plus 1. In order for us to have 13, we're simply adding 1. So if we do that to say we are simply adding 1, 1, 1, and so on this number that we now have, if we add a 1, what are we going to have? It will be like this, x plus 1. We add a 1 like this. So 1 plus 1 is what? Is 2. So meaning to say the other number or the third number is going to be x plus 2. If x is the first number and these numbers are increasing like that, consecutive. So the question is, we are supposed to determine using an equation. So what is going to be our equation? If we add these, because they say the sum of 3 consecutive. So if the first number is x, we add the second one, which is x plus 1. We add the third one, which is x plus 2. This sum of these 3 consecutive, the first one, second one, third one, following each other like that sum, it is supposed to be equal to 39. That is our question. The sum is equal to 39. So what are these numbers? In order for you to find these numbers, simply solve for x. By solving for x, you are determining the first number, because let the first number be x. So simply solve. All right, so let's find this, add the terms of x. This is x plus x plus x, which is same as 3x. This is 1, 1, 1. So 1 plus 1 plus, which is 3x. We move on to the numbers. 1 plus 2, which is 3, is equal to 39. So transpose the 3 to the other side. What are we going to have? We're going to have 39 minus 3, which is going to be 36. So meaning to say our 3x is equal to 36. And we need x. So if 3x is equal to 36, what about x? Simply divide by 3. So x was going to give us 12. Where x is representing the first number here, the first one. So if the first number is 12, what about the second number? 12 plus 1, which is 13. What about the third one? 12 plus 2, which is 14. Or you can just add 13 plus 1, which is what? Which is 14. So these are the 3 numbers that you're being asked there. Determine with the use of an equation the 3 numbers, If we add these numbers, 12 plus 13 plus 14, we must get the total that we're given, as we are being told that the total is 39. of these three numbers. So questions can be given like that. All right. Let's consider another question on 1.7. Solve simultaneously for x and k. Solving this, it is in your hands. You can choose to work with elimination, substitution. That one is in your hands. So you're given 2k plus 4k is equal to 20. 7k plus 3k is equal to 19. So let's say we want to use elimination. I'm just going to start with elimination. Then we could also use the substitution. If we are using elimination method, so let's say we are using the elimination method, and let's say we want to eliminate the part of k. All right, there is x there. This is 2x, this is 7x. Let's say we want to eliminate the part of x here, where x is. I simply have to interchange these two numbers because this is 2, this is 7. So on my first equation, I'm going to multiply it by what? By 7 on top. Second equation by 2. We just have to interchange these numbers. 7 multiplies everything, okay? Seven times 4, which is 28. 7 times 20, which is 140. We are done with the 7. The 2 multiplies everything in this case also. 2 times 7, which is 14. 2 times 3, which is 6. 2 times 19, which is 38. Remember, what is it that you're supposed to calculate? You're supposed to calculate the value of what? The value of k by eliminating x, because you can see that the part of x is the same. So now x can be eliminated. 14 minus 4, we subtract that. 14 minus 14, which is a 0. 14 minus 14. Then 28 minus 6. So what are we going to obtain from there? Because we have to subtract. 28 minus 6. Okay, so this part that we had, that was a negative. All right, actually in this case here, I wanted us to see this way. This was taken as a positive on this question, but the question they wanted you to have, it was supposed to be having a negative here. I forgot to tell you this one here. They just made a mistake on this positive. It was supposed to be negative here. That is how the question was supposed to be. It was supposed to be a negative there. So can we just correct that part? All right. So if you check your question paper, yes, you can see that there is a positive, but the sign that they wanted to use there, it was supposed to be what? A negative. All right. So that is the one that you're going to work with. So this is going to give us a 0, 14 minus 14. Then this will be 28 minus 6. A minus and a minus is what? 28 minus 6. So a minus and minus, that's a positive, which will give you 34. So 34, 140 minus 38, that was going to give you 102. Then divide by 34, k was going to give us a 3. So I just want us to correct that part. They, these guys, sometimes they just make some mistakes. They wanted to use that one as a negative. So we just need to correct that one. So after finding the value of k, you can even substitute in any of these equations that you want. You can put it in the first equation. It's up to you. 2x plus 4k is equal to 20, where our k is equal to 3. So that's 2x plus 4 times k, remember, is 3. That's 20 there. So 2x, 4 times 3, that's 12. So we take it to the other side, it will be a minus there. 20 minus 12, which is 8. So that's if 2x is equal to 8, then divide by 2 to obtain what? To obtain the value of x. So that our x was going to be 4. So that is how we're supposed to have answered this question. Using the substitution method, remember, like I said, guys, this question, it was supposed to have a negative. So please just correct that and use that one, the negative there. So we are going to use the substitution method. Using the substitution method, guys, we can see that there are two equations there from your substitution method. This is your equation 1. This is your equation 2. You just make what is easier to be the subject. You can make x to be the subject in equation 1, which is easier for us to make x the subject. If 2x plus 4k is equal to 20, you can make this the subject. So 2x is equal to, take this 4k to the other side, it becomes a minus. So that's 20 minus 4k. We want to find x, divide by 2 each and every term. So as you can see, you can have our x. So x is equal to 20 divided by 2, which is 10, minus 2k. So this was going to be our equation 3. So using the substitution method, we can now substitute equation 3 into equation 2, not equation 1, because remember, you made the subject from equation 1. So you substitute in another equation. So substitute equation 3 into equation 2, equation 2, where we have got x, we are going to substitute this part representing x. So that's 7 into x, which is 10 minus 2k. The rest remains as it is. So that will be minus 3k on this part is equal to 19. So like I said, guys, let's have this as a negative as it was supposed to be. So expanding the brackets, 7 times 10, that's 77 times minus 2 minus 14k minus 3k is equal to 19, like that. Then we can collect the like terms. Minus 14 minus 3, that is minus 17. So that's minus 17k is equal to 19. So taking the 70 to the other side, what we're going to have, this 70 to the other side, that was going to be a minus. So you have to subtract 70 there, meaning to say minus 17k is equal to 19 minus 70, which is minus 51. So we can divide by negative 17 by negative 17 both sides. That's determine the value of what? The value of k, which was going to give us a 3. So this is from your substitution method. As you can see, for the same value. And we can actually substitute this k into equation 3. It's easier for us to work with the equation 3 because already there x is the subject. So that's 10 minus 2k, where our k is 3. So meaning to say our x was going to be 10 minus 6, which is a 4. From this, we're going to obtain a 4. So as we can see that these questions, they just a repetition of questions that you are going to have in your typical revision. So that was a question 2. As you can see, question 2 was having a lot, 34 marks on question. All right, sorry, this was just a combination. All right, this is still question 1, is just everything. All right, so 1.7, that's the whole of question 1, guys. As you can see, it was a lot. So like I said, on your question paper, there is a positive, but the sign that they wanted to use there, it was a minus. So even if you have to go through your memo now, you see the calculations are not corresponding to what you're supposed to have. So these are some of the mistakes which are happening there. We just have to try by all means to understand that those mistakes, they do happen as they are setting up these question papers. Some of these things, they do happen. On question number 2, it was a direct question that we need to consider. They say Jamie bought a small business for 250,000. The business generated 1,000 in the first month and then generated a monthly income of 3,000 thereafter. It is to generate, that's a profit. So the first month, it was 1,000. The second month, it had a profit. Thereafter, or each month, the money deposited into, so they're saying each month, the money is deposited directly into an account so that his savings grow over time. No interest is added. Each month is added. So meaning to say, if you have this 3,000, which is the interest, because it is, if the business is generating that, it is the money that you are getting as a profit, as an interest. When they say no interest is added, we are not considering any interest like the rate of any interest that is considered. We're just considering the profit as it is. So they wanted you to complete the table below. So the first part, we had a profit of 3,000, of 1,000. So this is our initial month. We started with that. The next month, we have a profit of 3,000. We have to add that 3,000 to what is given here. So 1,000 plus 3,000 was going to give us what? 4,000. So our A was going to give us 4,000. Thereafter, as it is continuing, 3,000, we add that again, 3,000. So 4,000 plus 3,000 is what? That's 7,000. That's a 7,000. We have another profit again of 3,000. Each and every part is being added. So 7,000 plus 3,000. That is where we get what? The 10,000 that we are having at the end. That was the type of our question. There's a difference of 3,000 as it is going. So the question is now saying, how much money will be there in Jen's account after any month? After any month, how much money is going to be there after any month? So if we take a closer look of this question, we were going to see that there is a difference. This is the bank balance, remember. So there's a difference of 3,000, 3,000 from this T2. The first one, we cannot say it was having a negative balance, but we want to start from this T2. There's a difference here of 3,000. 4,000 minus this, there's a difference of what? 3,000. This one minus 4,000, there's a difference of 3,000 and so on. So if we are to consider, that is simply number pattern type of a question, which is under our finance, but this is just a number pattern. This is just a number pattern, this one. So 2.2, our TN is equal to what? So our TN is supposed to be given, remember, where we have got a common difference, we are going to use the BN plus what? Plus C, where I said B is the common difference. So the common difference is the 3,000. So that's 3,000 N plus C. So we are going to consider, let's say, the second part, the third or the fourth. That is where the 3,000 is effective, because the other one will be having a negative value and so on, of which is did not start with a negative. So if you consider T2, at T2, the second month, the money that was there is what? Is 4,000. So it means T2 is equal to 4,000. So that's a 4,000 here is equal to, N is 1 when you're referring to T2. What is your N? What is your N in that month, in that first? All right, so let's consider this one. After this profit, this is 4,000. Like after a month, we are having a 4,000. So this is important, guys. Here is supposed to be N1, like T1. This is how it is going to be like, so that you can understand each other here. Remember, the first one, the interest or the profit was 1,000. The profit was 1,000. But thereafter, the profit was maintained 3,000, 3,000, 3,000. So we want the TN, the linear pattern from this second term. So this will be 1, 2, 3. That is where a 3,000 effective is on. Because the first one, there was a 1,000. If it maintained with 1,000, it was going to be 1,000, 1,000, 1,000. So we cannot consider that as our first term. So there we have to be very, very careful. So in your substitutions here on this end, this is the first part where the 3,000 was effectively into use. This is the first part. So it was going to be 3,000 into 1 plus C. So take this, that will be 4,000 minus 3,000 is equal to C. So that is C is going to be what? 1,000. This is representing our C. So meaning to say Tn is equal to 3,000 N plus what? This C, which is 1,000. Meaning to say there's a month lagging behind in terms of our months. This N is in terms of months. So as we are going to make our calculations, we are supposed to consider there's a month lagging behind where the 3,000 was not yet effective from that. Where that was not effective at that particular condition, it has to be considered at the end to say what is it that we are supposed to have, because there's a month which is not considered that we left aside. There's a month that is left aside. So we have to be very, very careful, especially in our simplification. Okay, let's see this question so that we understand each other. Like this one, they are saying, how long will it take for this gem to break even? All right, to break even, that is to get his initial investment back. What is his initial investment? The initial investment is the one that is supposed to be done, this one, 250,000. Take note of what is happening there. 250,000. That is the one that we are supposed to have. But in this case, we are told that there is supposed to be a 3,000. That is each month. We are supposed to have what? 3,000. All right. So let's consider this separately here, which is 2.3. Our TN is 2,500 as we are to consider our simplification there. Right? Let's take it this way. I hope you understand me on this second question, 2.3. So TN is equal to 250,000. We take that as 250,000. This is the money that is supposed to break over up to that value. If we are to get to that value, which was initially given, or which we started with initially, if we can get to that value, that is our question. Where is it going to happen? At which condition, where is it going to happen? So it is just a matter of substituting in this case. All right. So I want you to see something there. 250,000 is equal to, this will be 30. This is 3,000. So that's 3,000 N plus what? Plus 1,000. We take this 1,000 to the other side so that we subtract it from 250,000. That was going to be 249. 249,000 is equal to 3,000 N. Then you have to divide by what? By 3,000 in order for you to get. And remember the N there, we are dealing with months. These are not years. These are months which are being considered. We are considering the months which were being taken. We are considering the number of months. So if we are to divide, our N was going to give us 83. This is what we're going to get from our N, which is 83. But remember that, like I said, guys, this part that is happening, it is considering to say, this is following the TN that happened, where we, remember how you took your T1 here, where the 3,000 was effective. We used the second month as our first month, considering where the 3,000 was effective, 3,000, 3,000, 3,000, 3,000. But what about the first part now? What about the first month when this 1,000 was into the bank? Because it was there. So we have to consider now that month that we had before. So therefore, our N is going to be 83 plus 1, which is 84. So we are going to consider 84 what? 84 months. So that is where this part here I was talking about to say, You are using 4,000 as T1. You are using that as your first month. Remember, you used it as your first month. But as we used it as our first month, what about the one that was there on that first month originally? Because there was something that was originally there on the first month that we did not indicate, that we did not show. It is because it was not maintaining the pattern of 3,000, 3,000. So that is why we had to leave that month aside. So as we left that month aside, in terms of our calculation, that month is supposed to be considered back in our calculations now. So that was the most important thing for you to consider in that case, to say you end up with 84 months, then you'll be wondering, where is the 8? There was a month that was a 1,000. This 1,000 that we had here, this part, we left that month. So it had 1,000, but we have to consider that. So that is our answer. But they said give your answer in what? In years. So 84 months is how many years? 84 months, we have to divide now by the number of years. So number of years, that will be 84 over 12. Okay, so that is, we have to divide now. 84 divided by 12, which was going to be what? Which was going to be 7 years. There is a month which was left behind. Please take note. That's here. T1, we started at 4,000. We used this as well. This month was left out for that 1,000. It must be given back. It must be given back. So the same thing on question 2.4, they are saying how many months from the date of purchase will it take, Jamie, to make a profit of 30,000? Give your answer in years and months. To make a profit of what? 30,000. So a profit, that's an addition, guys. From our TN, this TN that we had, now there's a profit. Remember that. Now there's what? A profit. Remember the break even, the money that is supposed to be on the break even is supposed to be what? 250,000. But if you make a profit of 30,000, it means now we are considering our TN as what? 250,000 plus the profit. We have to add the profit. So it was going to give us 280,000. When the profit is involved, the money is going to be 280,000. So that's in place of this TN that we used before. Now we are using this as what? Okay, that's our 2.4. Now we are using TN 280,000. 280,000 is equal to what? 3,000 N plus what? Plus 1,000. Remembering that there is 1 month lagging that we are supposed to involve in our calculation. And this N represents the month. So take the 1,000 to the other side, you subtract, it was going to give us 279,000, which is equal to 3,000 N. Divide by 3,000 both sides. Divide by 3,000 both sides. That was the value of N, which is 93. So you're going to obtain 93 months. But because of that 1 month lagging, that one that we did not involve in our calculation of that 1,000, we are supposed to add that one back. So plus 1 month lagging behind that we did not involve. We are talking of 94 months. So 94 months, those are the ones that we are talking about. To have 280,000, we are going to consider 94 months. But remember, before we said we need how many months? In this case, we need 84 months to get to 250,000. When we add the profit, we need how many months? We need 94 months. So the difference now is where the profit, the difference in terms of the month is now the profit. So the months that were being taken to get to this one, to get to 84, guys, what is the difference between this one? 94 minus 83. What is the difference there? If we, that is 80, 84. Remember, our N is what? 84. Here, 84. That was going to give us 10 months. So the 10 months is for the difference of these guys. But already, remember, when you are 84 months, you have already covered how many years? You have already covered 7 years in full. So there it is simply saying we have got 7 years, 10 months. Or you can even, guys, divide by what? By 12. You are going to have a remainder of what? Of 10 months. So that is the difference between this 94 minus 84. So we are going to take 7 years and what? And 10 months in order to obtain that profit. Meaning to say we have to cover the money and we also have the time to cover the profit. It is involved. So guys, they can ask questions like this type one. You have to be very careful because here they were testing you here. Here, please be very careful, especially here on this finding of TN. We could have said our TN like this. TN, after finding that TN, remember it was 3,000. It was given like this. 3,000 N plus 1,000 like this. We can say whatever that we have here, after finding, we are supposed to add a certain value. But now it is going to affect it is affecting N here. So for you to have that, guys, it will be complicated. So ignore that because the TN is taken from when we have a linear pattern. So the first part here, it was not a linear pattern. The 1,000 that we had, it was taken from deposit 1,000, 1,000, and we do not know what was happening there. But thereafter, it was maintaining 3,000, 3,000, 3,000, 3,000, 3,000, 3,000. From which term? From this 4,000. So we have that as our first term, second, third. Then that first month that we had, it is just a month that we are borrowing behind that has to be added in every calculation that we have to make. That has to be involved. It has to be involved in that calculation. So just like here, you calculate, you get 93. You add that month that was lagging behind. So we talk of 94 months. Same part as how we calculated here. You calculate your N, which is 83 months, but you have to add that to 1 month, which was carrying a 1,000, which was on its own. That was the type of a question that we had. And it was, it needed you to be very, very careful in terms of the approach. In terms of the approach there, you needed to be very, very careful. So if we are to consider on question number 3, we are given our functions, that is the graph of f of x and also the graph of gx, where x is greater than 0. That is the instruction that you're supposed also to put into consideration for the values of x to be taken above or to be greater than 0 are drawn below. So on this information, or on the sketches that we have, or on these graphs, we can see that there is a point A, which is the x-intercept, this one. The point A, as we can see, it is the x-intercept affecting the part of this graph of f of x and also affecting the graph of g, this one. All right, as we can see in our x-axis, remember, this is your x-axis there. So it is having an intersection at this point. So between these two graphs at this point, then we are also given and point of intersection for both graphs, okay? That is the x-intercept and point of intersection for both graphs, okay? Which is fine. Then B is the turning point. So as we are to consider this B, that's a turning point at 0.09. And we are given, that is the turning point of F and CD. This one is a vertical line that you're given. So if you are to consider this type of a function and the presentation of our function, the way it is given, this quadratic function, we can tell that the y-axis that we are given is the axis of symmetry. And this point B that we are given, which is the turning point, this one, it is also the y-intercept. They're saying it is the just being told that it's a turning point, it tells us that this y-axis, this one, is the axis of symmetry. So it is the y-intercept, also a turning point there. So you must be careful as you are to answer your questions, all right? Just understand your graphs. So this is what you're given, 3.1, write down 3.11, the range of f. The range of f, as we are to consider our f. This is our f of x. Remember, range, we are talking about the y values. These are the y values that you're talking about there. So that is the range of what? Of f. The y values are limited to the turning point. We cannot exceed that turning point. So the y values, they are going to be less than or equal to 9. They are less than this, the y values, less than or equal to 9. And this y that you're talking about is actually a real number that will be represent all the real numbers. So you can actually also present that this is an element of what? The real numbers, the real terms. Then also they want you to determine the domain of G. The domain of what? G. All right, that's 3.12. There we have to consider the domain of what? Of G. This is our G. What is it that affects the domain? These are the X values. It was not going to be limited in terms of the X values, but because of this instruction that we are told that our X are supposed to be greater than 0, that becomes the domain of our G. So X is supposed to be what? X is supposed to be greater than 0. You can also indicate that this is an element of real terms, of which just writing X is greater than 0, there is just 1 mark, guys. You're going to obtain the full marks. 3.13, the equation of the horizontal asymptote of G. The horizontal, you're talking about this type of a line, that's the horizontal. So the horizontal asymptote of G, they're talking about this one, the horizontal line that you're given. So what is the equation of this line? It is of y is equal to what? Remember, all these horizontal lines, y is equal to where they talk of the y value. In this case, this is y is equal to 0. Remember your x-axis. So the same with this one, it is of y is equal to all horizontal lines, their equation. If it was at another point, maybe on top like this, y is equal to a certain value. At this point of 9, like this one, y is equal to 9. That is how you write the equation of a vertical line. So what is the y value? We simply need our function g there. On gx, we are given, this is 3. It is given, our gx is given as 3 over x minus 1. So this is the limiting value that we are given, which is the asymptote at x is at y is equal to minus 1. So meaning to say, we can take it from our equation. It was not given on our graph. This is y is equal to minus 1, meaning to say it passes at minus 1. And this part is of x. This x, there's nothing that you're given on x. So x is equal to 0. But we are not worried about x because the one for x is the vertical. If they say the vertical, that one is for x. If they say the vertical. But in this case, they're not talking about the vertical. They're talking about the horizontal. So y is equal to what? Y is equal to minus 1. That is from the horizontal line. So this one, it was going to be of y is equal to minus 1. 3.13, write down the values of x such that f is decreasing. We need the values of x for which f is decreasing. This is our f. As we are to consider our f from this graph, it is going up. It is going up. That is increasing up to the turning point. From the turning point, our graph now starts to decrease. That is to reduce in terms of the values. The y values, they were increasing before. Now they are decreasing. Like this will be 9, 8, 7, 6, decreasing, decreasing, decreasing up to negative values. There we started with the negative going up. So from this point here, where x is equal to what? Because we're talking about x values in this line, what are the values of x? In the y-axis, that is the question. In the y-axis, what are the values of x in the y-axis? Remember, in the y-axis, x is equal to what? X is equal to 0. So meaning to say we are comparing from x when it is at 0. We are comparing these values. What are these values? 1, 2, these values of x, because x is going 1, 2, 3, and so on and so on and so on. So compared to this 0, these values 1, 2, and so on, we are comparing them to 0. How are they compared to 0? They are bigger than, they are greater than 0. So in this case, our x values, when f is decreasing, it's on a condition where x is greater than a 0. And you can also write, it's use an element of real numbers, but for 1 mark, you can even leave it like that. That's it. That's it. Just like that. Then 3.2, they want you to determine the values of A and Q for 4 marks. Determine the values of A and Q. So it will be best that you determine this where there is an equation which is having that A and Q. Is there an equation? Yes, it's there from f of x. So from f of x, we are given that f of x is equal to a x squared plus q. That is where we have a and q. And we are told that b is the turning point. Remember, q represents the value of y at the turning point. What is the value of y there? Remember, y is what? 9. So q, we can simply take that one. It is equal to 9 at the turning point. That is the value of y at the turning point. So if q is equal to 9, to find a, let's substitute into this. Remember I said before, if you are given f of x, it simply means y is equal to. So y is equal to ax squared. Remember we obtained that q is equal to what? Q is equal to 9. So we can determine the value of a by substituting any point which lies on this function f, as long that point is found on f. But we cannot use the turning point because it is the one that represents a 9 there. Using that, you are simply neutralizing your equation. There is nothing that you're going to get from there. So meaning to say there is a need for us to have another point which lies on what? On f, which is found on this graph. Is it point C? Where are we going to have it from? Is there anything that we're given about C? There's nothing. Because C lies on F, but there's nothing that we're given about C. So there's nothing that we can use. What about A? We can take this A because it is something that is found on both functions. Remember, A is the x-intercept. It is also the point of intersection of both graphs. So we can take advantage of the A that we are given because it is found on both graphs. Remember, it is the x-intercept, and we know that in the x-axis, y is equal to what? Y is equal to 0 in the x-axis. So from gx, we can take that one and see what is the value of x there. So let's work from what? From g of x. Remember, g of x is given as what? 3 over x minus 1. That was 3 over x minus 1. From g of x, the point A, we have to determine the point A. What is the point A? We do not know, but we know that a point is made up of x and y. So taking an advantage that in the x-axis, because this point lies in the x-axis, where y is equal to 0. So we know that y is already a 0 there. We know that y is already a 0. So if we understand that this is same as y is equal to 3 over x minus 1, it simply means in place of that y there, we are going to substitute as 0. So 0 is equal to 3 over x minus 1. Remember, when you are calculating the x-intercept, y is equal to 0. So solve for x. It's an equation that you have where you need to solve for, x. So take the minus 1 this side, it becomes a positive. 0 plus 1 is what? 1, which is equal to 3 over x. Remember, you need to solve for x, and 1 is same as 1 over 1. So we can simply cross multiply these two. 1 times x, which is x, 1 times 3, which is 3. So that is x is equal to 3. At this point, we have point A, which is what? 3, 0. It's a point which is found on both functions, this one. That's why we are using it as to our advantage. It is found on both functions. So substitute the point A now that you're given, which is 3, 0. Remember, that simply means X and Y. So we simply have to substitute what represents Y. Y is equal to what? Y is equal to 0. When X is what? When X is 3. So it's A times 3 squared plus what? Plus 9. We cannot have this value of A without a point which lies on what? Without a point which lies on F. We must determine first a point which is found on F, then substitute that point using X and Y. So in place of Y, we substituted, which is 0. In place of X, we substitute 3, as it is here, in place of X. So we can solve for A now. So that is 0 is equal to 3 squared. 3 times 3, that's 9. 9 times A, that's 9A plus 9. Take the 9 to the other side. The moment it jumps the equal sign, it becomes a minus. So that's 0 minus 9, which is minus 9 is equal to 9A. So 0 minus 9, that's minus 9, guys. All right, divide by 9, both sides. So what is the value of A? That is going to give us a negative 1. So if A is minus 1, we have already solved, guys, because the question was to find the value of A and the value of Q. So Q is equal to what? Q is equal to 9. A is equal to minus 1. We are not even asked to write the function, but if you want, because maybe you might need to use that one, remember, we can just write it aside. This does not even affect us, all right? So let's just write aside. Remember, f of x is equal to, that is ax squared, and we solved that A, and we got our A as what? Negative 1. So that's negative 1x squared. So it's supposed to be like this, guys. But negative 1x squared is the same as what? Negative x squared, isn't it? That's the same. So negative x squared plus Q. Q is what? Q is 9. So that's our f of x. But we are not asked this. I'm just saying we can just write aside just to know. This is just for you guys to know what you're talking about. Not to say it is something that is affecting our calculations. No. It's not an effect to us. All right, number 3.3. If hx is equal to minus f of x minus 3, we talked about this in November 2022 exam. We had a similar question like this. Then they're asking you to write down the equation of h. Simply substitute because you have f of x. Okay, so now you see that importance of having that f of x. This is f of x here. So they are saying here, all right, 3.13. We need to find hx. All right. How can I answer this type of a question? This is 3.31. We are told that hx is equal to minus f of x minus f of x minus 3. This is what you are given. So we can simply substitute, guys, what we have, because we have that f of x. Remember, by substituting the a and the q, we wrote our f of x like this one. So simply substitute. This is minus into the whole part of f of x is being affected by a negative. The whole part, this one. So that is minus x squared plus 9 like this. This is what it means, minus f of x. After that, subtract a 3. So that's a minus 3. That is what they mean. Then from there, simplify. So we can simplify further, meaning to say hx is equal to what? It's multiplied by a negative. Negative times negative here, that will be a positive. You're distributing. That's x squared. We multiplied here, the negative times this, that's a negative 9. And already there's a minus 3 that we have. So we are simply going to subtract that. So meaning to say our hx is equal to what? X squared minus 9 minus 3, that's a minus 12. That is our hx. That is the equation for hx. And from that hx, determine or write down the coordinates of the turning point of h from there. Coordinates of the turning point. Guys, we saw this from q here, from this one that we had when it was a q. The turning point is 0 minus 9. The value of q here, we just take as it is the value. What is the value? 9. The coordinate is what? 0, 9. So what about this one? Because they are saying from hx, from this one, from our hx, what is representing our q? This is the minus 12, this one. So meaning to say the turning point is already there. So our turning point, the value of x is 0 there. But y is what? Y is the one that we know it is minus 12. The turning point, because it is along the what? The axis of symmetry that is along this y-axis. We're talking about y-axis there is the one that is affecting. So if your graph, even if your graph is like this, it'll be symmetrical about the y-axis. So the turning point value is one that you take. It'll be symmetrical about any other graph that you're going to have as long the y-axis is given like that. So this is the type of a function which you write its equation in the form of f of x is equal to ax squared plus q like this. In this format, the turning point is the q. So if there's a minus there, your turning point is 0 minus q. If it is a positive, your turning point is 0 q. That's the turning point, this one, the value of q, just like that. So if you're given this, guys, you can take that one in an easier way. That is understanding of your graphs. It is very, very important. If we move on 3.4, they want you to write down an equation. Write down the equation of the line of symmetry of G, which has a positive gradient. I talked about this in our previous class that the line of symmetry can be given in two ways. We're talking about this G. The one that has got a positive gradient and the one that has got a negative gradient. But as long as you are referring to the line of symmetry, guys, the idea is the same throughout. The idea is the same. What you just need to know is that, is it having positive gradient or is it having a negative gradient? All right. So that's our 3.4. So they said we need the one with what? Positive gradient. So the one that has got a positive gradient is given in the form of y is equal to x plus c. If it has a negative gradient, y is equal to minus x plus each and every line of symmetry that you are calculating, guys, that is how it is going to be calculated as from a hyperbola. So it's supposed to be taken each and every part. So we need the one with a positive gradient. This is the format. So how do you find the C? I said before, to find the C, you need now the asymptotes. From the asymptotes now, what is it that we have on the asymptotes on this hyperbola, on this gx? The x, I talked about it. This is the an asymptote. X there is equal to 0. That's an asymptote. X is equal to 0. Then another asymptote, we saw it on y is equal to what? On y is equal to minus 1. So the point of the asymptote is the one that will help you to find the C, because that line of symmetry, it passes through the intersection of the asymptotes of the axis, that one, where they meet. So we are going to use our asymptote. X is what? X is 0. Y is what? Minus 1. It's a point. You can just use that way or just substitute, guys. You know that y is minus 1. You know that x is just substitute there. In place of y, minus 1. In place of x, we substitute a 0. So what is the value of C? That is the question. So minus 1 is equal to 0 plus C. That's a C. Remember, if you add anything to 0, it will remain as it is. That number remains as it is. 2 plus a 0, that's a 2. 0 plus a 2, that's a 2. So 0 plus C, that's a C. So C is minus 1. Therefore, our equation is y is equal to x minus 2. Remember, plus or minus, that's a minus. Remember, like this. Plus or minus 2 like this. So it will give us a minus 2. So that is the idea there. The one with the positive gradient. If they say the one with the negative gradient, you're going to use y is equal to what? Minus x plus c. Minus here. That is the only difference that we have. So do not even worry about this type of equation, guys. It's going to be a repetition. Check also November 2022 exam that we had. There was a question also like that. 3.5. The length of CD, if the equation of line CD is x is equal to 1, we need the length of CD. If the equation of this line CD, the equation is x is equal to 1, find the length of CD. That is the question. Find the length of CD. In the question paper of November 2022, I talked about this type of a question, but it was on a horizontal line, if you still remember. We were given a horizontal line, and I said, on a horizontal line, in order for you to have length, let's say this is our x1, this is our x2. The length between these, you just need the x values. You subtract x2 minus x1, the difference between these two. But if it is a vertical line now, like this one, this one is a vertical line that we are given, that we are told before. That's a vertical line. So on a vertical line, what you need are the y values. You need the y value. You also need the y value. So let's say this is y1, this is y2, whatever order that you have. The difference between these is the length. So the length of CD is simply the difference, y2 minus y1. What is the y value at C? What is the y value at D? Because we already know the x value is 1. The x value is not going to change throughout. At this point D, x is equal to 1. At this point C, x is equal to 1 because it's a vertical line. The x value is the same. X is equal to 1 there is the same throughout. So what is the y value now at point C? How are we going to obtain the y value here at point C if we know that x is 1? Where is C found? C is found on what? On F. It lies on F. It is found on F. So if it is found on F, we can find the y value by substituting the x value on what? On F. Remember our f of x, guys, from our f of x, when we substituted that value of a, our equation was minus x squared plus 9. Remember that, guys. And we are saying at a condition where x is equal to 1, what is the y value when x is 1? So this is minus 1 squared plus a 9. That was going to give us minus 1 plus a 9, which is 8. So it means the y value at point C, the y value corresponding here is equal to 8. That is the y value that we have. We just need the, guys, working with the vertical line, concentrate on the y values. Yes, you can use a point. I'm not saying it's wrong, guys, to say this is point C. So I know that x is 1. So I write this as a 0.18. It's fine. You can use that as a 0.18. You do the same thing on D. What is the y value at point D? Where is D found? D is found on this graph. On the graph of what? On the graph of G. That is where D is found. D is found on G. D lies on what? On G. So D lies on what? On G. So if it lies on G, let us substitute y is equal to what from our gx. Remember our gx, 3 over x minus 1. That was our function, 3 over x minus 1. And we know the x value, it is not going to change at a condition where x is 1. We substitute the value of x that we are given, which is 1. So what is the value of y? 3 over 1 minus 1. That was going to give us a 2. So the y value at this point is a 2. When x is equal to 1, the y value at D, a point which lies on what? On H, or on this G. The point D, the point which is lying on what? On this G that we are given. X is what there? We know the value of x. X is 1, does not change. So even if you wanted to write it as a point, because the x value is the same, it was going to be 1, 2. You use the distance formula, the distance between C, use your distance formula, x2 minus x1 squared plus y2 minus y1 squared. I'm not saying it's wrong. You can use that. You substitute your x values. As you can see, they're the same. 1 minus 1. So that's 1 minus 1 squared. Y2 minus y1, 2 minus 1, 2 minus 8. So you're going to have that plus 2 minus 8 squared. You have a distance. But using this idea of just knowing the y values, I say the distance or the length of CD is the difference between these 2 points. So you just have to subtract 8 minus what? 8 minus 2, which is equal to 6 units. So that is the length, the distance between these 2 points on a vertical line. That is the same answer that you're even going to, or that you're even going to have if you're using this one. You're going to have 6 units there. That is the same. You're going to have 6 units. But it is an advantage for you to know this. You consider the y values when dealing with what? A vertical line. When working with a horizontal line, you have to consider the y values. What is the y value at this point? What is the, I mean, this is now horizontal. What is the x value there? What is the x value there? Then the distance that you consider, or the length that you consider between these two, is the difference. You just have to subtract x2 minus x1. That is, you are considering what? A horizontal line. What is important are the values of x. So let's say I know that the x value here is maybe I'm given -2, -3, and here the x value is 2. What is going to be the length between this point? The difference, I just have to subtract 2 minus this one, the bigger number, minus the smaller one. So 2 minus -3, that's a +5, meaning to say we have got 5 units in between. The difference. So that if you're given horizontal lines, guys, and vertical lines, that's how you simply work with them. So this one, it was on a vertical line. Let's move on to another part and see. Now they want you to determine the values of x such that f of x is greater than x plus 3. All right. They are saying we need values of x, all right, such that f of x is greater than x plus 3. So this is what I want you to take note. In most cases, this is how it is supposed to be like. Let me just remove this part so that you can understand each other. In most cases, this is how this question is supposed to be given as f of x is greater than 0, or maybe f of x is less than 0. We consider f of x compared to the 0 then. But in this case, guys, it is totally different. They are saying we need values of f of x or of x where f of x is greater than x plus 3. So you ask yourself, are we having this function? Because f of x is there, which is true. But are we having this one, the function of x plus 3 on this graph? Is it given there? It's not given. It's not drawn, this one. It was not drawn for us. So for you to draw, it is going to be difficult because let's say you've drawn your line like this. You know that they will intersect here, but you do not know the values of x. You are going to be forced to calculate these values of x. So instead of you drawing that line, we can solve it direct from our f of x. How can we solve this direct? We have to substitute because this one is given, f of x. Remember, we calculated this when we calculated a and q. We got minus x squared plus 9. So it must be greater than x plus 3. It's an inequality to be solved that we are used to in our simplification. Remember your quadratic inequalities. That's what we have there. So this is minus x squared. Take the x this side, it becomes a minus. That's minus x. We take the 3 this side, it becomes a minus. 9 minus 3, which is +6, is greater than 0. So avoiding having this as a negative, we can avoid that. Divide each and every term by -1. Each and every term by -1. So this is going to give us x squared, negative, that's +x. 6 divided by -1, that's -6. Remembering that the moment you divide by a negative, the inequality sign reverses, it changes. So it is now less than a 0. 0 divided by -1, that's a 0. So the inequality sign reverses, meaning to say this is our new inequality to be solved, this one. That's our new inequality to be solved, this one. We now have a new inequality to be solved. Inequality to be solved. Where it is less than a 0. So how do we solve inequalities? Remember, when you're solving inequalities like this on a quadratic, you need what you call the critical values. The critical values are the values of x that we obtain when we make this to be an equation. X squared plus x minus 6 is equal to 0. You obtain what you call the critical values. As if you're solving a normal equation. As if this is a normal equation. How are you going to solve this? By factorization, 2 brackets. It is equal to 0. Remember that this is the coefficient of x squared is 1. So just consider the factors of what? Of -6. Do we have factors of -6 that will add up to a +1? The number that you're given there is a +1. So what are the factors? The products of -6. 2 numbers. You multiply these 2 numbers. you get a minus 6. But when you add the numbers, you must get a positive 1. So there's a possibility between 3 and 2. But one of these numbers must be a negative. So let's try minus 3 and 2. And 2, this one, 3 and minus 2. Let's try these two. When this one is a minus, if we multiply, yes, we get a negative. But when we add minus 3 plus 2, minus 3 plus 2, that's a minus 1, which is not a positive 1. There we need a positive 1. These two, if we multiply, we get a minus 6. Let's add and see. If we add 3 plus minus 2, what is that we get? We get a positive 1, which is exactly what we want. So these are the numbers that we need there. A plus 3 and a minus 2. So from these brackets, remember one of these brackets must be equal to 0. So what will be the x value, guys? Remember that x plus 3 is equal to 0, or the bracket of x minus 2 is equal to 0. You take the minus 3 to the other side, it becomes a minus 3. Or x is equal to minus 2 to the other side, it becomes a positive 0 plus 2. That's a positive 2. These are the critical values, not the solutions to our inequality. We were solving an inequality, not an equation. So critical values, they help us now to determine the exact inequality that you're supposed to have. It's in between what? It is showing us that it can be found in between minus 3 and in between a 2. The values which are in between, how do we indicate these values that are in between? We can write them as x is greater than minus 3. X is greater than minus 3, but less than a 2. Now we have it from what? Our presentation of the function. Or we can use the number line concept. Remember the graphical concept to say we have a minus 3 here, we have a 2 here. Let's say this is our function because this is a positive. So we are going to have a smiley shape like this. So where is it that we have on our function from this new inequality where it is less than a 0? Where our function is less than 0. Remember, this is the part where y is equal to 0 here. So being less than 0, that is below here, below the x-axis. Remember, the x-axis, the equation, is y is less than 0. So values in between minus 3 and 2, how do you combine them to a single inequality? That's x is greater than this, but less than a 2. That is what they're asking you to do there. So questions can be like that, as we can see, where we need to actually formulate our own inequality from the statement that we are given. Sometimes it is a direct question because you can see it from the diagram. Okay, this is the line is already drawn, but if it is not given, or whatever that inequality that you're given, it has nothing to do with this function, and form an inequality that you need to solve. No, your basics of your inequalities, because you did inequalities as a separate topic, remember. As you know how to solve your basic your inequalities, you're supposed to do it like that. On question number 4, we are given the exponential function. Consider this exponential function of tx, where tx is 2 times 2 to the exponent of minus x minus 4. From this function, they are saying write down the range of t. So the range, remember, these are the limiting values of y. So we can obtain the range from the y values there, which means y is supposed to be bigger than minus 4. Y is greater than minus 4. For which values of a y that you're talking about? Any real number that you have. So you can even indicate for any real number that you're given. But for 1 mark, you can just write y is greater than minus 4. On 4.21, calculate the x-intercept of t. That is our question there. Calculate the x-intercept of t. If this is our t, we need the x-intercept. How do you calculate the x-intercept? What is the condition of the x-intercept? In the x-intercept, y is equal to 0. So when y is equal to, remember this is y is equal to, so you're going to substitute 0 is equal to 2 times 2 to the exponent of minus x minus 4. Then we just have to solve for x. Minus 4 to the other side, that's a positive 4, is equal to 2 times 2 to the exponent of minus x. How do you find this? Divide by 2. That's a product there. So 4 divided by 2, that is going to be 2 is equal to 2 to the exponent of minus x. Automatically, the bases are the same. Remember, if the bases are the same, we focus with the exponents. Same bases, same exponents. That is the idea of our question in that case. All right. Sorry for that. Sorry for that. This is what we need here. So same bases, we know that the exponents are also the same. So 1 is equal to minus x. From this, we can divide by -1 by -1 so that we have the x value. So x is equal to what? X is going to be a -1. So if x is -1, that's the x-intercept is -1, 0. Remember, y is equal to 0 there. Okay, so just like that, guys, the same thing about the y-intercept. So the y-intercept, we know that x is supposed to be 0. So in place of x, just substitute a 0 there to determine the value of y. 2 times 2 to the exponent of minus a 0 is just like a 0 there. Minus 4. So that's going to be 2 to the exponent of 0. Remember, guys, any number raised to the exponent of a 0 is what? It's a 1. So it's same like we have got 2 times a 1 minus 4. So that was going to give you a minus 2. All right. So that's the x value. It's a 0 and y is minus 2. Then they want you to sketch this graph. All right. So we can actually sketch this graph, guys, because we have got everything showing clearly all the intercepts with the axis and the asymptote it is supposed to be given. So thus, we have an exponential function with a negative. So it is supposed to be something like this. I'm just going to put a sketch, guys, but it's just supposed to have something a little bit visible. All right. So in this case, remember your asymptote. It is the one that is affected here at -4. So this graph is not going to pass -4. It is going to be limited at what? At -4. It is going to be limited here. But we have the x-intercept and also the y-intercept. We are given the x-intercept at -1. So let's say this is where we have our -1. The y-intercept at -2. Let's say this is -1, -2. Let's say this is where we have it, -3, and so on. So meaning to say our graph is going to pass at -2 and at -1. And it is going to be tending to pass through this, but it won't because that's an asymptote. So our graph is just going to be like this. All right, passing through -2, tending as if it is going to be approaching this, but it is not approaching because that's an asymptote. It won't cross this line. So that is the idea of the asymptote. So that is how our function of t was going to be like on our sketch. And there, I want you now to describe the transformation of t to h. If hx is given by this, what is the transformation from t to hx? Okay, let's consider our transformation, guys. Let's consider our transformation and see how did this graph actually transformed from how it was before. That is our question 4.4. Originally, our tx is given. This is our tx. Now it has transformed to another function, which is hx, which is given by 2 times 2 to the exponent of positive x. So we can see that there is no effect that happened on this 2. It is the same 2 that we had here. The effect happened on x, direct on x. It was minus x before. Now it is a positive x. What happened? To say we had a minus x, now it's a positive. We simply multiplied the x value by a negative. It is the x value which was multiplied. This part of x, it was minus x. We multiplied it by a negative. So it is the x value which was multiplied by a negative to give us this positive. So which type of transformation is this one? Where we write it as f of minus x in this way. That's a reflection about the y-axis. So in order for us to transform from this minus x to the positive x, that was a reflection, this one, about the y-axis. About the y-axis. If it is given minus f of x, where the y value is the one that is affected like this. This one is a reflection about the x-axis. It is the y values which will be affected like from that consideration. But here it is x which is affected direct. So we say it's a reflection about the y-axis. That is the first transformation. If we check originally on our function, there was a minus 4 here. But on this one, there is nothing. It simply means there's a 0 there. There's nothing. So what happened in order for us to change from minus 4 until we get a 0? What happened? We simply added a 4. Minus 4 plus 4 is what? It's a 0. So when we added a 4 here, what transformation is it? To add the y value. That's a translation going up. A minus, you're going down. Plus, you're going up. So also, there was a translation to change from minus 4 to 0. It was a translation which occurred. So there's a translation there which occurred. Okay? Translation of what? Of 4 units upwards. Going up. There was a translation plus minus 4 plus 4. That's what? That's a 0. So that is the transformation you are simply being asked to say. A basic question, guys. All right. On question number 5, they are saying, study the advertisement below. Buy an iPhone XX for only 229 Rand per month. You have 24 months to pay. No deposit is required. That's a higher purchase that you're given there. 5.1, calculate the total amount to be paid over a period of 24 months. As we are given, you have to pay 24 months that you have to pay. So meaning to say the amount can be calculated here simply. The amount paid per month, we are paying what per month? 229 each month times how many months? 24 months. You just have to multiply to 24. That was a straightforward question, guys. So this was going to give you 5,496 Rand. That is the amount to be repaid in 24 months to be paid. 5.2, the monthly installment quoted in the advertisement, this one, is calculated on a hire purchase agreement, which charges interest 7.5% per annum on cash price of the cell phone. On cash price. Show that the price of the cell phone is originally before this hire purchase that had occurred. So what is this amount? That is the principal amount. So they want you to show that the principal amount is equal to this, the original price of the phone, which is the cash price of the phone. That's what they want you to show us. Remember, you have this amount which accumulated, and it's a higher purchase. Remember, higher purchase, we deal with what? Simple interest. I talked about this from your finance guys. This is simple interest. So under simple interest, the amount is given as what? This is P into 1 plus I, and under simple interest. So we need to show that the principal is this amount. If is this value that you're given, is if our amount is this, because this has to be paid over 24 months. 5,496 is equal to P into 1 plus the interest, 7.5 divided by 100. That was going to be 0.075 times the number of years, 24 months in years. 24 divided by 12. Remember, 1 year, 12 months. That was going to give us 2 years. So the N, the number of years, is going to be 2. You multiply that one by 2. So that is the idea of the question. You need to calculate P. So simply divide by this bracket, 1 plus 0.075 times 2. Both sides, you also you have to divide this side also 1 plus 0.075 times what? Times 2. That this is going to cancel. And what is that you're having? The principal. So the principal is equal to this. Divide. So you are going to obtain 4,779.13 to 2 decimal places. As we can see, this is what they wanted you to show. Show that the amount, the principal is that. That is the cash price of the cell phone. If you are to buy this cell phone, you're supposed to buy it with this price. But because of a higher purchase, yet this person, or if you are the one, you have to pay 5,496. So the question later on wants us to calculate the total interest paid over 24-month period if the cell phone is bought using this higher purchase agreement. So the interest, guys, is simply the difference. Remember, on a higher purchase, this is what you have to pay. But originally, this cell phone that we are talking, the same phone that we are talking about, which has to be bought with this price, over this period of 2 years that it had this to accumulate, it was taken from this principal, this one that we calculated, which we proved there, the principal. Over this period, the money was this, but it has to accumulate to this amount because it's a higher purchase. But this is the cash price, this one. So the interest is simply the difference that we are seeing between these two. That is the interest. The difference amount. It was what? Yes, this is the price that you have to pay. You have to pay 5,496. From which price? From this original cash price of what? 4,779.13. From there, we have what? The interest. So we are going to have an interest of 716.87. That was the interest to be paid from what originally was supposed to be paid. You're supposed to pay this amount, but because of higher purchase now, you have to pay 716.87 extra amount. That is a sort of interest that you're talking about there. On question 5.4, the cost of the cell phone is subjected to inflation. Remember, inflation, we are talking of what? The compound interest there. Compound interest formula. So they are saying it is subjected to an inflation and increases to a cash price of 5,100 after 2 years. Calculate the annual inflation rate as a percentage. If it is subjected to inflation, it means it is subjected, which amount is that is subjected to inflation? The cash price, our principal amount, this one, is the one that we are talking about, not the one for higher purchase. This was something that was on an agreement. From this, and remembering this is inflation that we are talking about, where inflation we deal with what? We deal with the compound interest formula. For inflation, amount is equal to P into 1 plus I to the exponent of N. So the amount is the one that inflation has caused to be at what? 5,100. Where the principal is our cash price of the cell phone. The cell phone was originally bought at what? 4,779.13. Then this is 1 plus the interest rate is the one that we need as a percentage. And N is the number of years over a period of how many years? After 2 years. After 2 years. So the formula is straightforward. Substitute your values, then you can calculate the interest then. So we can divide by this. Is 4779.13. Let's divide and see what we are going to have. All right. So after dividing, we can see that there is a square that we have there. So we can simply remove that square by introducing the square root. We introduce the square root. Introducing the square root, we are removing the square. So we can also take the 1 to the other side. So it will be a minus. So it is going to be the square root of 5,100 like this over this. It was 5, it was 4, not 5, this one. This one is 4 there. This one is 4. And we correct this. This is a 4. So that's 477.9,13. Everything that we are having after simplifying this square root, we must subtract a 1. This one, we take it there, we subtract it. So this is what we are going to have, which is going to give us this I that we are seeing there. And that will be a decimal that you are obtaining. You are going to obtain a decimal first, 0,033, 02, and so on and so on. But as a percentage now, you must multiply this by what? As a percentage. So that was going to give us 3,30%. As a percentage now. That is our interest rate. That is the one that was affecting this inflation at what? at 3.3%. On another question, they are saying the same cell phone is sold for £250 on Amazon UK. So remember the Amazon, they gave the amount in pounds using the following exchange rate. Calculate the price of the cell phone in rand, which is in South Africa, in South African rand, on Amazon UK. They gave us an exchange rate. So it is just using that exchange rate because they are telling us that for each and every pound that we have, it is equivalent to what? 22.32 rand. And we have got how many pounds? This phone is charged 250 pounds. So what is the equivalent in terms of the rands? We do not know. So you can just even cross multiply, guys, and you've got your answer there. So 1 times x, that is x is equal to 250 times what? 250 times 22.32. So our x was going to give us 5,580, which is in what? South African rands. So this is the amount that you're going to pay for 250 pounds. It is equivalent to what? 5,550. So there it was just a direct conversion of your values, the amount that you're given. On question number 6, in a random experiment, A and B are two different events. Suppose the probability of A is 0.4. The probability of B is K, 6.11. If the probability of A or B is, if it's an assumption that we are given, suppose something like that, for which value of K is A and B mutually exclusive events? When these two events are mutually exclusive, they are separate, A on its own, B on its own. So I said it before that if two events are mutually exclusive, the intersection of A and B is equal to 0. There is nothing on the intersection. But A and B now, the probability of A or B is important, that it must be equal to the probability of A plus the probability of B. That's being mutually exclusive events. Because we do not have this intersection. So that's an equation that we can actually use this one. We can solve this equation. Because we are given the probability of A or B, it's what? 0.6. It is equal to the probability of A. What is the probability of A? 0.4. Plus the probability of B. What is the probability of B? It is K. So solve for K. We take the 0.4 to the other side. So that's 0.6 minus 0.4, which is going to give us what? 0.2 is equal to K. So on this condition, K was going to give us what? K was going to give us 0.2 from that condition of being mutually exclusive. That's a condition that you are given. You work with that. On 6.12, that's another condition that they want us to use. What is it that we are supposed to use this time? They are saying for which value of K is A and B complementary events. What will be the value of K there if they are complementary events? Remember, complementary events, the probability of A plus the probability of B must be equal to 1. I talked about that also. So if they are complementary, this is what we're going to simply need. The probability of A, we are given. What is the probability of A? 0.4. Plus the probability of B. What is the probability of B? That is the K that we do not know. But it must give us a 1. So we can solve for K. Take this to the other side, 4, which means our K is what? So question there. From there, we are given in this in a class of 60 learners, 8 learners take history, 41 learners take mathematics, 61 learners. Calculate the number of learners that do both history and mathematics. If it is to be represented on a Venn diagram, we just represent in terms of X. There are two events, history and mathematics. There is history and what? Mathematics. And since they want you to find those ones who do both, it means there's an intersection like this. There's what? An intersection of the two. Those ones who are taking history and those ones who are taking mathematics. So X, let it be those ones who take both. But they told us that 8 learners, they take history. History, they're 8. The whole of this set, it's 8. So what about history? Only this one. That will be 8 minus x. What about mathematics only if we are given that 41 learners take mathematics? What about mathematics only? We have to subtract again 41 minus x. Then we are given that 16 learners take neither of these two subjects. What does it mean? They do not take these two. These 16, they do not do history, they do not do mathematics. So that is our information. Remember, the whole of this sample space that you are given is equal to 60. All the learners that you are given, they are 60. So that's an equation that can be solved there because we are told that calculate the number of learners that do both. So both, that is where we have got our x. So as an equation, if we solve this, 8 minus x plus this, okay, x plus the 41 minus x plus this 16 that we are given, it must give us the total number that we have, which is 60. So that's an equation that you just need to solve. That's an equation that you need to solve. Considering the numbers on their own, 8 plus 41 plus 16, what are we going to have? That's a 65. The part of x minus x plus x, that's a 0 there. We are left with what? We are left with minus x. It is equal to 60. So minus x is equal to what? Taking the 65 to the other side, it becomes a negative there. So it's 60 minus 65, which is minus 5. So let's divide by negative 1. By negative 1 like this. So x was going to give us what? A positive 5. That is the value of x, which means we are talking about those ones who are doing both. That is the one that is having both in this case. Calculate the number of learners doing both mathematics and history. That is 5. So if you understand like the diagram, how it is important just for you to know that. So our x there was going to be equal to what? Was going to be equal to 5. So after that, they want you now to draw a Venn diagram to illustrate the above information. But you'll be wondering to say, I have that Venn diagram now. They want you now to put exactly the values that are there here. What are the exact values that we are having there? Instead of us writing the 41 minus x that we are writing there, right? Instead of us writing this 41 minus x, what is it that we have there? 8 minus x. Remember, x represents what? 5. This x, it's a 5, this one. That was a 5. So if we had this part as 8 minus x, it simply means 8 minus 5, meaning to say there are 3 people that we are going to consider here. 41 minus x, it's able to subtract 41 minus 3. We have to subtract each and every part, which was going to give us 41 minus 5. I mean, this is 5. Remember the intersection, not 3. 5. We have to subtract the 5. 41 minus 5, which was going to be 36. Then we write the number exactly that we have there, which is 36. That is what they mean. When they ask you the first question to find both, then they want you the Venn diagram. They want you to have exactly that Venn diagram. Put in exact values. On 6.23, determine A, the probability that a learner taking history only. History only. So what is the probability that a learner is taking history only? If we have a diagram like this, we are not going to struggle this one. How many people are there? There are 3. So the probability there, it is 3 out of the total, which is what? 60. So reduce this on your calculator. That is going to give you 1/20, or can even have it as a decimal. You can also have it as a decimal. It's up to you. Then B, you can also have it as a percentage. It's up to you guys. The probability that a learner does not take mathematics, meaning to say a learner does not do mathematics. How many learners do mathematics? 41 learners take mathematics. So if 41 learners take mathematics, this question is simply asking you to calculate the probability of maths complement, not mathematics, not part of mathematics. So it is simply 1 minus the probability of those who are doing mathematics from 1. The probability There are 41 learners that are taking mathematics. So that is 41 over what? Over the total. Remember, our total is 60. So that's 41 over 60 like that, which is going to give us 19 over 60. Or we can simply have it from the diagram. Those ones who do not take math, these are the ones who take math. You close close this set of math. This is maths. When you close this, what is remaining? There's this 3 and this 19. Those are the ones who do not do math. They do not take math. These 3 and these 16 outside. So 3 plus 16 is our man, 19. So that was simply the same. 19 over what? Over 60. Just like it can use anyway. Then we had this question when we revised the September 2024 exam that I think it was supposed to be KZN. We had a similar question like this where you are given that the probability that a mathematics learner is also a science learner. They are saying the chances of saying those ones who are doing mathematics and those ones who are doing science, they are equivalent. That probability is 0.297, 0.927. It can also be given as a percentage. They can say it's 92.7%. They are simply saying these two, they are equivalent. So to determine the number of learners that take science, we simply have to use that probability that we are given to say the science that we have, it is going to be from the probability multiplied to those ones who are taking mathematics. Because we are saying the chances of doing mathematics and chances of doing science is the same. So you multiply the probability to the number of those ones who are doing mathematics. How many learners are taking mathematics? 41 learners take mathematics. So you can simply multiply that to 41. The learners who are taking mathematics, because it's just equivalent like what we have on the science. That is the idea there. So having a probability is an approximation now. So that was going to give 38,007, which is approximately 38 learners that we are talking about in this case, which is having a learner doing science and also is doing math. It's just one and the same thing. So let's work out as many questions as we can so that we understand these questions. They do repeat these questions. If you check properly your questions, you will see that it is just a repetition. So that was it, guys, for you to obtain 100 marks. Let us continue to revise in light as we are revising for our exams, which are ahead of time. Keep on revising your question papers and also understanding the basics of your topics. It is important that you also go through the topics, understand each topic as they are given, the introductions of each topic. It can help in your revisions. Till we meet again.